Well, it's that time of the week again. It's time for Chitchat Across the Pond. This is episode number 815 for June 8th, 2025. And I'm your host, Allison Sheridan. This week, our guest is Bart Bouchotts. The show's a bit unusual, so before we hear from Bart, let me explain why he's on the show. On Chitchat Across the Pond number 814, our most recent episode, Adam Engst and I discussed the results of a VPN survey he conducted with the Tidbit subscribers. From there, we got into a discussion where Adam challenged the common wisdom that we need a VPN when we're on public Wi-Fi networks. We got a bit mired in some of the discussion where we almost had enough knowledge to explain our positions. Networking is a topic on which Bart has a depth of knowledge, and he's here to clarify some of the things we talked about. The recording you're about to hear was created for the Security Bit segment on NosillaCast number 1048, but I felt it was important for the Chit Chat Across the Pond audience to hear it as a follow-on to our discussion with Adam. Well, it's that time of the week again. It is time for Security Bits with Bart Bouchotts, and I'm very excited, especially about the first topic this week, Bart.
Well, me too. And it gives me another excuse to say how much I love how wonderfully well yourself and Adam are giving new life to a segment I still feel like a sort of a granddaddy of or something. You know, Chit-Chat Across the Pond is kind of my idea as an excuse to talk to you.
Oh, 100. I hope you don't feel ousted.
Oh, no. I love the fact that yourself and Adam are having these amazing conversations. I think it's so cool.
Good. And we still have all of our segments together, so everybody's happy.
Exactly. Actually, we've no feedback or follow-up, so we can jump straight into our deep dive, which I've called some VPN Nuance, because in the Chit-Chat Across the Pond, which was included in the last NosillaCast and as the most recent standalone Chit-Chat Across the Pond, I forgot to check the number.
I can come up with it while we're chatting. Well, keep going. I'll just throw out a number all of a sudden.
Well, I was going to say, it's linked in the show notes, which is kind of the most important thing. But you guys had a very good discussion on deep linking, which is just so useful. I don't know when I discovered that, but actually it was probably Adam who posted it on Tidbits is probably when I discovered it. So a few weeks before you guys recorded, probably. But it's a great feature.
That deep linking is fantastic. It just, it's life-changing. It was number 814.
Excellent. Well, you also then had a discussion on VPNs, and I don't actually disagree with you. I have a minor quibble with something Adam said, but it's a quibble, and we'll quibble it at the end. But there were two things.
Well, I think throughout it, I kept saying, I just feel like I'm missing something here. Like I don't have something in my arsenal to respond appropriately here. And I was assuming somebody would correct me, and it's even more fun if you're there to just bring some sanity to it.
I hope so. There were two little threads you guys left dangling because neither of you were quite sure enough to be assertive. Which is better, right? If you're not sure, don't tell the listeners a porky pie. Just sort of leave it and hope a listener.
This is what I think I know.
Yeah, exactly. So I want to pick up those two loose threads, and then I'm going to have a little quibble with Adam about the importance of protecting your DNS, because Adam is half right, but missing a piece, and that piece is, in my opinion, important. But I noticed you guys struggling a little to have the discussion because you didn't quite go deep enough into how it really works, which meant that you were talking in abstractions or analogies. And those analogies are really useful, but they're limited. They're not an exact analogy of what's really happening. And so when you get to the edge cases, the analogy breaks down. And you guys didn't dig deeper, which meant you couldn't answer some of the questions very convincingly. So I'm going to do what I do. And I'm going to pour in a whole bunch of context. And you're going to be, why are you telling me this? And then I'm going to pull it all back. And then hopefully you go, oh, look, it's tied up in a neat little package. Fingers crossed.
Can you give us any kind of a level set of what it was we did say? Or
okay,
will that
yeah,
come out
sure.
in the discussion?
Well, no, I can tell you now. So the two things were you had some queries about what iCloud Private Relay doesn't do. That's really easy to address. We get to that at the end. That's a nice, easy one.
Okay.
That's a paragraph. And the other question, to which the answer is it's complicated, but it's very interesting, is are you on the LAN or not? When you connect to a VPN, are you on the LAN or not?
Right. So that was when I was talking about being in a coffee shop and saying you don't want to be on the LAN where you can get an adversary in the middle attack.
Yeah.
And then we got into, are you on the LAN?
Yeah.
Okay.
Yeah. And that's the complicated one, but it's good reason to dive in. So
and LAN being local area network, by the way.
Oh, thank you. Yes. And I'm going to do another little acronym thing while we're here because there has been a change in terminology. And I don't know if people have noticed that the new term you see a lot is AITM. It's all over the place now. And I don't know if we ever explicitly connected the dots between that new term and an older term we've used for a long time called MITM, or man in the middle. They are not different. They are an updated version of each other. So man in the middle is the old phraseology that is falling out of use. And adversary in the middle, or AITM, is the new term. And the reasons for the change is twofold. In 2025, the adversary is more likely to be an automation or an AI than a human. And why do we need to throw a gendered term in there when it probably isn't human at all? The actual term is probably it. So how about adversary, right? Whether it's a human intelligence or some other intelligence, if it's against you, that's the bit that matters. So AITM.
And why couldn't women be doing awful things being adversaries too? So
yeah, true. Although in cryptography, it's always poor Alice and Bob. But anyway, don't know why that. All right, that's a whole other thing. So all of this lives on our modern networks, which are all TCP/IP networks. And the TCP/IP network is one of the most amazing things I learned about my computer science degree because it is just genius. And the thing has stood the test of time since the 70s, like 1970s. We're still using it today. The only thing that's changed is it's a million times faster.
You said all of this lives on TCP/IP. What do you mean by all of this? You're
Everything
talking about
VPN.
the VPNs?
Yes, absolutely.
Okay.
Everything we do, everything involving the LAN or the internet is TCP/IP networking. It is how our whole planet hangs together. It's amazing because it's 70s. And it's such a big problem. They didn't try to solve it all at once. They broke it into pieces, 4 layers, and each layer solves a different subset of the problem. And the only way the layers communicate is that they only talk to their direct neighbors, and the layer below you offers you services that you don't have any idea how it's done. All you know is I can ask the layer below me to do this. And you offer services to the layer above you. And all the communication just happens in that way, with each layer offering features to the layer above and depending on the layer below. And so everything is broken down into those 4 layers, including VPNs. So layer 1 is at the very, very bottom, and it is only it's a real electronic engineer layer. It is worried about getting one single packet. Oh, I've left out a sentence. The genius idea from the 70s was that instead of trying to send a whole bunch of data as one big stream, you break it into little pieces, and each piece lives by itself. You break it apart, you shove it into the network, and then you put it all back together on the other end, which is why they're called packet-switched networks. Each packet is independent, which is mind-blowing that that's how it works. When you send like a 1 gig file, it's a few million packets. It gets broken apart, they all go across the internet. Half of them could go a different way than the other. One of them could go across the Pacific and some of them across the Atlantic if it's going from me to you, right? And they'll all just get reassembled in your computer, and it's like, oh yeah, there's the file, Bart. Thanks very much. It's magic.
Okay.
So the first layer in solving that problem is really straightforward. Get one packet from one device connected to the same physical network to another device on that physical network. That's it. That's the only thing layer 1 tries to do, which means that there are 2 important things from our point of view. Layer 1 for us is Ethernet. That is what layer 1 is. It's Ethernet, which means on layer 1, the only addresses involved are MAC addresses. Your packet goes from one MAC address on your LAN to another MAC address on your LAN, and we have 2 implementations of Ethernet. Little copper cables we call wired Ethernet and Wi-Fi. They are both Ethernet. Layer 1.
Right.
Layer 2 then is responsible for getting one packet from any computer connected to anyone's LAN to anywhere else on the internet. So one single packet still, but now you're not just getting it within your network, you're getting it to jump from network to network to network to get from me to you, say, other side of the world here. And the way you jump from network to network is through routers. So routers connect two networks together, and the packet goes from my router to another router to another router to another router, bing, 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 and eventually it arrives at your router and pops onto your LAN and onto your Mac. And that's quite a job of work, figuring out how to do that. So that is the magic of layer 2. And at layer 2, the protocol that does all the work is IP, i.e. IPv4 or IPv6. So IP addresses are how IP packets are addressed. The packet goes from one IP address to another IP address, and they could be anywhere on the planet.
So let me make sure I follow this. So you said that layer 1 was getting individual packets from one directly connected device to another, but then layer 2 is getting individual packets from one internet connected device to another internet connected device. What does mean directly? Layer 1, what is directly connected?
Your LAN. So layer 1 only goes as far as your router. And then it's not layer 1 anymore. It goes up to layer 2. Now, your router has another layer 1 connection to your ISP. So it goes up to layer 2. Your router decides what to do with it. Back down to layer 1 to go to your ISP. Comes back up to layer 2. Another router decides, do I go left to go across the Atlantic or right to go to Amsterdam?
Okay.
Back down to layer 1. Pops up at the next router. Left or right.
Okay, I hope you don't mind. I added in parentheses on your LAN right after
perfect.
one directly connected.
Yeah.
Okay.
Yeah.
Now I'm caught up. Okay. All right. So now we've got things flying across the internet, still individual packets though.
There we go. So layer 3's job is to put some sanity on this individual packets thing. So at layer 3, we are dealing with data streams. So you have a stream of data goes in on one side, and that same stream is supposed to come out the other side. And we have two protocols here that you will probably recognize. The Transmission Control Protocol, or TCP, or the User Datagram Protocol, or UDP. So TCP and UDP. And at layer 3, the little packets have an extra piece of addressing. It is IP address plus port number. So at layer 2, it's IP addresses. At layer 3, address port numbers come into play. So MAC addresses on layer 1, IP addresses on layer 2, IP plus port number is layer 3. And then layer 4 is where the applications live. It's called the application layer. And so that is everything that you think of happening over TCP IP. So some of it is low-level network stuff. DNS is a layer 4 protocol for translating IP addresses into pretty names that we humans can remember. NTP, the Network Time Protocol, is a layer 4 protocol for synchronizing clocks. And then the other stuff that lives in layer 4 is the apps you and I care about. So email is layer 4, SMTP, POP, IMAP. The web is layer 4, so that is HTTP. File sharing and stuff is layer 4, so your SSHs, all the proprietary stuff, that's all layer 4. Instant messaging apps, they're all layer 4. So all that stuff is layer 4 up in the application layer.
Okay.
So that's your normal network. So now someone came along and went, I want to make a VPN. I want to make it so that we can pretend that there's a private cable between these two computers in different parts of the world that I can send data through so that no one can spy on it. And the way it's done is by using a layer 4 protocol like WireGuard or OpenVPN. And on the two ends, you have an app. And that app creates a virtual network card. So this is like in Loopback, we can make virtual audio devices, which are connected to a piece of software. So where a real mic is connected, a real audio input port is connected to a microphone, which is magnets and wires and things. And a Loopback one is connected to some software. Do the same thing for a network port. So a new network device appears in your Mac or your Windows machine or your iPhone. It has a name as if it was a physical network card you'd installed, but there's no copper wire, there's no antenna. It goes to the app. And then the app encrypts whatever data is sent in that layer 2 hole, that pretend network port, encrypts the data, And then it sends it over your real network using the layer 4 WireGuard protocol or the layer 4 OpenVPN protocol.
Okay, head spinning a little bit by now, Bart. That was a lot of up and down the layers for me to follow.
That is the key point.
I don't have a specific question,
okay,
but I don't follow it.
Well, no, ask.
Say it again.
Okay.
No, but I don't have a specific question. I just got tangled up in the up and down in the layer 2, layer 4.
Okay, so you have an app at each end. That app is the brains of the operation. And the app is connected to the internet on both sides. So they can talk to each other over a layer 4...
What app?
The VPN app. So let's pick one. Let's say you have NordVPN installed. You have a piece of software running on your Mac called NordVPN. They have a matching piece of software running on the NordVPN server called Nord server or whatever the heck they called it, right?
I didn't know an app was running at the other end.
Yeah, because it has to be listening on a port, remember? Yeah, so yes is the answer. You have software talking to software.
Okay.
Because it's layer 4.
So I'm with you so far. So I've got a layer 4 app on each end.
So they
then what?
Are going to talk to each other over layer 4, and what they're going to send over and back is encrypted data, which is not different to what Signal does, right? It's you take some data, you encrypt it, and you send it over and back. But they don't want it to be text you type, right? That's not the job they're trying to solve. They don't want to encrypt something you type in a text window. They want to encrypt network traffic. So how do they get the network traffic? They lie and they make a pretend network card and say, any traffic that goes into that pretend network card, we are going to encrypt and then transmit as a bunch of effectively data, as if it was a file. And then on the other end, we're going to decrypt it and shove it back down to layer 2 out of another pretend network card. And then it can carry on along the internet as if it was any other network connection. So they're simulating a network connection in software and sending the data over your real network connection.
Okay, so layer 2 again is one internet connected device to any other internet connected device.
Yeah.
Without the VPN, it's using my regular network card. I'm already got one internet connected device to another internet connected device.
But you don't have encryption. The data flowing would be going straight from where you were to where you wanted to go without any protections. A VPN gets it from here to there, but instead of going straight through the public internet, it goes up into the app, encrypts the bejesus out of it, sends it not to its final destination, but to the VPN server, decrypts it, and then lets it back on the internet as if it had come from there. It teleports the network connection.
Okay. All right. I think I'm with it so far.
Right. So the key point is the data is still traveling across your physical LAN. It's just wrapped in a layer of encryption. So at a very fundamental level, are you still on the LAN? Yes.
Wait, back up. You just used the proof to say the proof. How am I still on the physical LAN?
Okay, the VPN is using a network connection from your computer to the VPN server to send data across the internet.
Yes.
There is only one physical connection between you and the internet. That is your LAN. If you were not on your LAN, how would the app send the data?
Okay, but it's not encrypted when it's traveling across my LAN.
It doesn't know what it's sending, right? A TCP packet is a bunch of glop. That glop represents the same data you would have sent without encryption, only it's now...
But it's encrypted.
It's now encrypted. It's now wrapped in a layer of encryption.
So that tunnel is happening inside my LAN, right?
You're right. So at layer 4, it's encrypted. But underneath, it is traveling as layer 2 packets.
Which are encrypted.
The data in them is encrypted, but the packets are still plain old layer 2 packets. So at a layer...
That doesn't make any sense to me. I don't follow the difference between the two.
Layer 2 doesn't understand what it's moving around. It is take this tiny piece of information which you have no idea what the big picture is. This could be half of an image. It could be the word hello. It could be anything, right? Layer 2 does not understand that it is moving something that belongs to a jigsaw puzzle that's a big picture. It's a tiny thing, and it makes its way entirely independently from one computer to another. It doesn't understand anything above.
Okay. Doesn't answer my question. Aren't those packets encrypted? It can't get it without it being through this VPN software. That's
that is
on both
correct.
ends.
But at layer
So
2, it is no different to any other packet because no packet makes any sense at layer 2. So at the layer 2 level, it is IP packets moving around. So you are on the LAN. They are moving over your LAN. If you weren't on your LAN, how could they travel?
It's essentially like saying you are on the internet.
Right.
You're on the LAN, you're on the internet, because the two things can't be connected to each other without the LAN existing.
Yeah.
And the internet existing.
Yeah.
Okay, so on the LAN, what I meant when I was saying it was visible, unencrypted, just flowing around where everybody can see it who's on the same LAN. Like Steve can see Steve's machine can see what's going on my machine on the LAN right now. That's what I meant.
Yeah,
if it was encrypted on the LAN.
He can see those packets, right? He won't be able to decrypt them, but he can see them. And he can even see that they're WireGuard packets or OpenVPN packets. He can see the source destination is your IP address. The port number is some port on your computer. He can see the destination is the NordVPN server at some random port. He can see its IP address. He is seeing those packets move. He just can't reassemble them into something meaningful. But each individual packet, he knows you are connected over WireGuard to NordVPN in our hypothetical example. I literally don't know what I can't remember what VPN you bought.
They're usually WireGuard or OpenVPN, so it doesn't matter. So it sounds like by definition, the LAN things on the LAN have certain knowledge that are independent of the encrypted information that you're sending.
Yes. And this becomes important because at layer 1, this isn't all that important because someone can know that you are using a VPN. So that's a tiny piece of information. So corporate policy could say, sorry, no VPNs, and all WireGuard packets could be blocked at the router. Your ISP could decide, oh, sorry, no VPNs. The government of China could decide, I'm sorry, no VPNs cross the Great Firewall of China. Right. So there is a tiny bit of information leaking, but that's not the reason I think it's very important to say that you're still on the LAN. Because the problem is at layer 1. The problem is Ethernet. Ethernet goes back to the 1970s. That means that Ethernet doesn't have any security. So when you are connected to a VPN, you are still on the network at layer 1. So all layer 1 shenanigans are still available to happen. So when there's a bug in Windows, that Windows has a remote code execution bug in its implementation of an Ethernet driver, you're still vulnerable. And there's a whole bunch of trickery that you can play at layer 1 that you're absolutely not protected from when you're on a VPN. There's another thing happening here. So let's leave layer 1, you just can't protect yourself from. Nothing can. Not even a VPN. What will happen is that if you are using HTTPS or if you're using a good VPN app, if someone messes with your layer 1, you will get a certificate error. So if you are the kind of human being who, if the web page gives you a certificate error, says no, you're okay. If you're the kind of person who a NordVPN gives you a certificate error, says no, you're okay. But if you open a VPN app, run it, the VPN app gives you a certificate error, and you go, oh, okay. All bets are off because someone on the LAN has successfully attacked you. You clicked okay.
Oh! You didn't say that part. So you're saying, how did I get the certificate error in the first place?
Because at layer 1, someone messed with you. And one of the things you can do at layer 1 is you can effectively steal people's traffic and all traffic that should go to the router to go to the internet goes to the baddie and then to the router to the internet. You can man in the middle people on layer 1.
Adversary in the middle.
No! Having so carefully laid it out at the start of the segment, I went in, yes. MITM. MITM.
Okay, so
you're still
not safe at all?
No. As long as you don't accept the certificate error, you are safe, right? If the certificates match, you're fine. So if you don't get a certificate warning, you are fine. But
you would always get a certificate error if someone somehow captures my layer 1 traffic, which I didn't follow how they did it, but they got to it, and I try to go to Google and they send me to something that looks like Google, but it's what causes a certificate error in that case?
So they're sending you to something that looks like Google, but only real Google has Google's private key. So fake Google can't do HTTPS or WireGuard or anything that involves encryption, because private key is the only way to match the known public key. That's the whole point of public key cryptography. That's how HTTPS works.
So they can't have a site with a certificate that makes it HTTPS, has a public-private key, and make it look like Google?
Correct, because only Google can get a certificate for google.com. You can't get a certificate for bartb.ie. You can only get one for podfeet.com because you have to prove domain ownership.
So we aren't talking about Google spelled with 3 O's. We're talking about google.com.
Bing, bing, bing. Okay. There's another point where the MITM position gives the attacker power. Right? Because if you don't notice the typo, right, you're still in trouble.
AITM, by the way.
Yeah, I know, I did it again. Oh. Right, so you can't hide layer 1. So you're on the LAN. So if there's a naughty person on the LAN, they can mess with you at layer 1. Depending on the configuration of your VPN client, they may also be able to see you at layer 4. Because your VPN app and the VPN app running on the VPN server are talking to each other over a TCP IP connection on some port number, right? Port 1 to port 2 over WireGuard. So there is a non-zero amount of layer 4 traffic. Otherwise, your VPN traffic couldn't be passing by. So how is it that it's sometimes possible when you turn on a VPN app to appear as if you disappear from the network? And I'm using the phrase appear as if, because the answer is you're not really gone. There's 2 things happening. So your computer, when it has more than one network card, has to decide, does this packet go to network card number 1 or to network card number 2? I have one packet, I'm sending it onto the network, I have 2 networks, do I go A or B? That's called routing. And your computer is a router. And if you have Wi-Fi and Ethernet, you need to tell your Mac which one gets priority. And you do that by dragging them around in your network settings. When you have a VPN, there's a third option. And so there's a rule that the VPN app tells your OS, every packet that matches this rule, you send it into the VPN. And that rule has to have an exception for WireGuard or OpenVPN, because otherwise you have an infinite loop where it's sending it to itself. Right? It's like looking into a mirror, pointing at a mirror. So there is definitely a rule that lets some traffic through. Now, you can use VPN technology to solve lots of different problems. And the different toggle buttons in your VPN setting will determine how the packet goes into, do I go straight to the LAN unencrypted, or do I go through the pretend VPN tunnel and go out through WireGuard? Right? So if you have a toggle in your VPN app for can access LAN, or can use local printers, or can connect to local file shares, you have these kind of toggles with different phraseology. That is telling your computer whether or not to let layer 4 traffic onto the LAN or not. If that toggle is one way, you do not even appear to vanish from the LAN. You stay completely on the LAN. You can use your Apple TV. You can use your printer if your printer feels like printing today, which it probably doesn't. You can access your Drobo. You're still on the LAN, right? But everything you try to send through the internet will be sent through the WireGuard tunnel. So you're still hiding from your ISP, but you're not hiding from your LAN. But maybe your VPN app has a toggle that says turn off LAN. Well, now the routing algorithm is saying to go this way, which means that traffic coming from you goes through WireGuard. But that doesn't stop someone else on your network talking to your shared iTunes library unless the VPN app also adjusts your local firewall inside your Mac or your Windows machine, because they all have a firewall too. So if they also turn on your firewall to say don't let the LAN in, then you appear to vanish fully at layer 4. But you're still there for layer 1 faffing about.
Okay. Well, it was suggested to me that it was insecure to use a VPN with local LAN access.
I wouldn't know. But no, what's the problem to be solved?
I need to be able to print, and I need to be able to securely talk over the internet.
Then that's not insecure. That's what you want, right? So the way I look at it is, what's the problem to be solved? Very nosilicast, right? So I'm at home, but I don't trust my ISP. Well, in that case, the LAN is trustworthy. The internet is untrustworthy. What I want my VPN to do for a secure connection is let me talk to my LAN. So in my own house, I'm by myself, right? I can do my stuff. Mm-hmm. But if I'm going to the internet, encrypt me. So then the right answer is to allow LAN access. But if I'm in a coffee shop with a whole bunch of naughty people, or if I'm at the one of those security conferences where they're always trying to hack each other.
DEF CON.
Right. Oh, Jesus. Well, then that LAN is hostile. So then the toggle should be the other way.
Okay. Okay, so it all depends on where you are and what you're trying to do.
Yeah, and the other one is, right, maybe you don't even want to encrypt internet traffic. If you work for an organization, maybe the only traffic that should go to the VPN is traffic going to your corporate network. Maybe your corporation doesn't want your Google browsing going all the way back to the corporate network and then out to the internet. Because maybe the corporate traffic only wants you to talk to the corporate stuff and to do everything else on your own bloody internet, please. Then the right configuration...
Can they do that?
Yeah. Now, that won't work with NordVPN. That will work with a VPN client provided by your employer, which will be OpenVPN with a pre-installed bundle named after your organization. And when you double-click on it, you'll say, connect to my company. And what it's doing under the hood is programming the routing algorithm with a really, really precise rule. If the IP addresses matches the corporation's IP address space, through the VPN. Otherwise, if it's for the LAN or for anywhere else on planet Earth, straight out, nowhere near the VPN, please. It's a perfectly valid routing rule.
Okay. Sure.
So it's a really powerful tool. So that's why when you say a simple question like, oh, but a VPN removes me from the LAN. Maybe. At layer 4, definitely not at layer 1, impossible. And how it behaves at layer 4 depends on the configuration of the specific VPN app. So the real answer is it depends.
So I was wrong.
Yeah, but Adam pushed back, but then when you asked him to justify it, went, yeah, I can't explain it. And then you left it hanging.
So I was wrong, he was right, but neither of us knew why either position was right or wrong.
Exactly. Now, I've front-loaded this discussion with the difficult part. Everything in this show is easier from here. So a really easy question to answer is iCloud Private Relay. Well, now that we have words, I can tell you that iCloud Private Relay exists 100% at layer 4. And there's actually a really nice developer video from the year Apple released it. It's 15 minutes long and it has all the nerdy detail, but I'm going to save you the bother. The only thing it does is 3 things. All of your web browsing traffic coming from Safari is double encrypted so that no one can de-anonymize it using the HTTP version 3 protocol over a very fancy pants protocol called QUIC, which is really efficient. Google invented it to do internet stuff faster. So it's HTTP traffic, which is encrypted. So it's HTTPS if you're going to get pernickety with me. But it is your web traffic with an extra layer of encryption being sent over the HTTP version 3 protocol. It does not cover non-HTTP stuff. So if it isn't from the web, it ain't going through that tunnel. The other thing that the Mac does when you turn on iCloud Private Relay is something very powerful that we have talked about, because the protocol is called Oblivious DOH, or ODO, which we joked about being like from Star Trek DS9.
Hang on, what does DOH stand for again?
DNS over HTTPS. So instead of sending out an utterly unencrypted DNS packet, you actually wrap the DNS question in an HTTP query. You talk to a DNS server that actually pretends to be a web server, and you send it a web request asking it for a DNS question, and it answers your DNS question as a web reply. It uses HTTP to tell you what IP address matches what domain name instead of doing it over the DNS protocol, which means you have all the protections of HTTPS.
I'm sorry, I lost how we ended up talking HTTP. What caused that?
Okay, so DOH is a protocol for doing DNS over HTTPS, which means that all of the leakiness of DNS evaporates and gets protected by the security of HTTPS. So it means that all of your DNS queries are encrypted anonymously if you turn on iCloud Private Relay. That's very powerful.
Oh, okay. Hang on. So you're saying without iCloud Private Relay on, my DNS queries are unencrypted?
Yes.
But if I turn on iCloud Private Relay, that's when I get DOH, DNS over HTTPS?
Yes.
Ah, got it.
Yes.
Okay.
Because it's happening at the operating system level. So that has to be an operating system feature. So that's one of the things that iCloud Private Relay does. The last feature it offers is one of those things it's called opportunistic encryption. If you install a third-party app, and that third-party app uses Apple's API for making HTTP without an S queries, then macOS or iOS with iCloud Private Relay turned on will adversary in the middle, where the adversary is the good guy, so helper in the middle, I'm making this up as I go along, will basically behave like an attacker in the middle, and instead of spying on you, wrap it in HTTPS for you and encrypt it for you and shove it through iCloud Private Relay. So it gets anonymized as well. It's called opportunistic encryption. But only if the app uses Apple's APIs. If the app is Firefox, which has whole different APIs because it's a bunch of C code that's shared across all the operating systems, it does it in C instead of using Apple's APIs. Well, it won't be affected by Apple's APIs. So it's a bonus, not something you can count on. So the two things you can count on are Safari will be anonymously encrypted. All of your DNS will be anonymously encrypted. So that is amazing. And then the third feature is, and we might make more of your stuff more secure, maybe, which is not bad.
Okay, so what we missed in talking about iCloud Private Relay, it is true that it encrypts our web traffic, but
that's it.
In our DNS queries, but it doesn't. But it doesn't take care of things like mail?
No, because that's all happening outside HTTPS. That's different protocols, so it just has nothing to do with it.
Okay, and it does protect apps if they followed Apple's APIs.
And only the HTTP part of the app. So if the app is talking a different protocol, add a picture as well.
Because it's already HTTPS, then it wouldn't be a problem. Or you're saying not even an HTTP request?
Right, it could be an IMAP request. It could be a Samba request doing Windows file sharing. It could be an infinity of things, right? Okay.
By the way, why didn't they call it attacker in the middle? Adversary in the middle is too many syllables. You just said attacker in the middle, and that was like that. Now I can remember the acronym because I can say it faster.
It's a word cybersecurity professionals love, adversaries. If you read the slides, they never talk about baddies or attackers. It's adversaries. Because it could be a government who are being a bit too spy happy. They're an adversary. But is it fair to call the Chinese government an attacker? Yeah, a bit political. Call them an adversary. Yeah. It's less political.
They're adversary to what I want.
Yeah, exactly. It's anyone who's contrary to my desires is an adversary. Whether that's malice or whether it's paternalism. Right, so call it adversary.
Okay. That was a little bit simpler to follow.
Is
there any other piece to this?
Yeah, so now we get back to me quibbling with Adam about DNS. So Adam very rightly said that because DNS is an old, icky protocol, anyone who manages to become an adversary in the middle can see your DNS queries, and they will see a UDP packet with zero encryption that says, please tell me the IP address for google.com. And they will see the answer coming back, and they will know that you were told that google.com is on whatever IP address it's on, which is obviously a privacy violation, right? If you go to some clinic for some embarrassing disease.com, even if you go over HTTPS, they will not be able to see which web page on some embarrassing hospital.com. But they will know you went to some embarrassinghospital.com, which leaks quite a lot of information. If you go to a church website, you're probably from that religion. If you go to a gay pride website, you're probably at the very least friendly to gay people. If you go to a trans activism website, the probability that you're non-binary in some way is significantly higher than random.
Higher. Right.
So there's data leaking through DNS, and that is to me already bad enough. And Adam says, yeah, it's not that. If you can live with that, it's okay. Minor quibble there. The problem is an unencrypted protocol with an adversary in the middle has an even worse problem. Not only can they see, if you edit an unencrypted packet, you won't create any sort of error. Your computer will believe the answer. So an adversary in the middle can redirect your traffic. If I lied to you over DNS, I can make you talk to whatever server I like. Because you asked...
Wait, but aren't I going to get that certificate error that says this isn't really myhospital.com?
You will for HTTPS traffic. And so at that stage, you're protected by not being the kind of human who clicks past warnings. But for Samba file share traffic, where you think you're asking something off your NAS, but you've actually just been sent somewhere completely different and sent the username and password for your NAS to some randomer because the Samba protocol is ick, right? You've just been lied to about where your NAS is, and so you've talked Samba instead of HTTPS. You've leaked a username and password. Maybe your mail server isn't doing TLS properly, so you're doing IMAP and with plain text usernames and passwords. Or maybe it's plain text access tokens, and what leaks out is an hour's worth of access to your email before the session expires. That's still an hour of getting to be you and resetting your password on lots of sites. So the fact that you can lie with DNS is dangerous. It means that you expose people to dialog boxes they may choose to ignore. Or worse still, if they're using even one unencrypted protocol, whatever they sent has leaked.
So that's a reason to have iCloud Private Relay on.
It is definitely a reason to have iCloud Private Relay on, which will protect you for all of your webby stuff. It's also a really good reason to have a VPN. Because if you're using a VPN, then all of that Samba stuff is going over the VPN. And NordVPN will always, it will tell your Mac or iPhone, doesn't matter what DNS server you thought you were using, you're using my secure DNS server now, which means that all of your DNS traffic on the commercial VPN apps goes straight through the VPN. And so the adversary in the middle loses all the DNS.
Okay, I don't want you to answer this, but the VPN that I've been choosing to use is Tailscale.
Oh, amazing. So amazing.
But I'm out and about. I turn on Tailscale. I keep it on all the time anyway, but I can set one of the devices on my LAN to be an exit node.
Yeah.
So my traffic goes into my house and then turns around and goes back out. So am I on the LAN?
Yes, very much so, because Tailscale's magic trick is to teleport you into your LAN so that you can do all of your home stuff from anywhere. And that's not a bug. That's a feature.
That is the feature.
Yeah.
Yeah. But it's sort of a twist your brain inside out problem as we're back inside the LAN again.
Yeah.
So do you see this DNS packets being not just a privacy risk, but enabling adversary in the middle attacks as a large threat vector for regular folks?
You see, none of these things at the moment. So if I have an unlocked door and I live up the Rocky Mountains, the theoretical risk is identical to an unlocked door in New York City. But in reality, if I lived up the Rockies, I'd leave my door open. I wouldn't do it on Fifth Avenue. So for most people, I am not seeing widespread AITMs happening on the LAN. I'm just not seeing it. So I think for normal folk who are not going to a dangerous place or who are not important people, be that a scientist or a business person or a campaigner or a government person, I don't. Right, I don't. Right, there we go. That's the answer. I don't. Okay.
So that doesn't mean don't use a VP, or does that mean you don't think people need it? The bottom line, do people, regular folk, non-activists, non-government officials, non-CEOs, would you say you've got to run or you really should run a VPN?
No, unless you're going to a place like China or something and you're doing something really weird.
Okay, so I was in Japan struggling with my VPN.
I wouldn't have.
Not letting me do some things.
I wouldn't.
Not a big worry.
No. What I would do, though, is turn on iCloud Private Relay so that all your DNS is protected.
Yeah. And do you keep iCloud Private Relay on at home?
Yes. Because it's easier.
Okay.
Just turn the toggle and walk away.
I remember turning it on at one time, but I'm pretty sure I get confused on there's one of the things messes up mail and makes none of your attachments show. And it came out at the same time as iCloud Private Relay. And I can never remember which one it was.
Well, I can tell you that iCloud Private Relay is fine to turn on, except when Apple have a server outage, and then iCloud Private, just like if your VPN provider goes down, your internet is fine, but if you're using the VPN, all of a sudden you lose your internet connection because the VPN just went down. Well, if you're using iCloud Private Relay and their servers go down, your DNS is gone. But then you go in and you turn it off, and it goes, hey, how about I just turn it back on tomorrow? And I go, sure, Apple.
Now, that's not advanced data protection. That's a whole nother thing,
correct.
Right?
Yeah, don't go there. That does all sorts of things.
Okay. So I can't find iCloud Private Relay.
Is that in iCloud settings?
Safari?
No, it's in iCloud settings.
It's in iCloud settings.
It's an iCloud feature.
It's just called Private Relay once you're in iCloud. There it is.
Yes. Sorry. Of course it is, right?
All right. I hope it's okay. I turned it on right while I was talking to you. Did
absolutely
I lose
safe, Alison. I have it on all the time.
Okay. All right.
And then
very good to know. I do want to thank Adam for saying all of this.
Absolutely.
Because I was unaware at all. This is great.
Now, I have one more thing to add. So there's a reason I'm much more blasé about not running with a VPN these days. And that's because modern Wi-Fi that you buy, not as a home user, but let's say that you're running a coffee shop and you pay someone to install Wi-Fi. They're not going down to the local, I don't know what, Curry's here in Ireland, whatever store sells a router to a home person. I don't know where you go. Circuit City, I don't know.
Best Buy.
Best Buy, thank you. They're not going to Best Buy and picking up a regular Asus router, right? They're installing an enterprise-grade Wi-Fi solution. And for the last decade or so, enterprise-grade Wi-Fi has had a feature called client isolation, which means that the router will only allow you to talk to the router and the internet. It will not take a packet from you and send it to any other user on the Wi-Fi. Therefore,
so you're not on the LAN?
Therefore, you're actually not on the LAN because the router is acting like a switch, and it's as if everyone has a private LAN. The way it actually works, under the hood, you have a LAN with you. You're the only person in your LAN. Everyone on the Wi-Fi network has a different LAN, is what's actually happening.
So we just came full circle, Bart.
Yes, we did.
You're not on the LAN.
If it's enterprise-grade Wi-Fi with client isolation turned on. and 90% of stuff in Starbucks, because they just contract that out. Like, there's a provider for Starbucks Wi-Fi for the whole of America, probably. They're not using over-the-counter stuff. They're using modern Wi-Fi equipment. They have client isolation because it saves them so much cleanup in aisle 4. The reason people turn it on isn't because they're trying to protect you. They're trying to protect themselves from you getting hacked and you getting all stroppy with them.
Okay. That's really interesting. But I wonder, if we stay at a little hotel in a terrible town. It's a terrible hotel. There was a cat in the hallway, a feral cat that walked into our rooms. It's a nasty little hotel, but it's near some family we love. The chances that their Wi-Fi has client isolation?
I can give you a test that will give you 90% confidence of a yes/no answer. Does the Wi-Fi work by a captive portal page where it asks me to give my room number, or does the Wi-Fi work by a post-it note hanging up in reception? If it's a post-it note with a shared password, it's home Wi-Fi. So if you have a coffee shop where the Wi-Fi password is thumbtacked to the whiteboard or something, that's home Wi-Fi. If it works any other way, it's not.
I don't know if that's a good distinction. So it's not a post-it note, but when you walk into the United Club at Los Angeles International Airport or the American Fancy Pants Club, they have a little card you get that tells you the password.
Sorry, that's not enterprise Wi-Fi.
Sure.
That is the old-fashioned way. They are not doing it the modern way. That is shocking.
Really?
Yes. If there is a password, it can't be the modern the modern networking, because it doesn't work with a pre-shared key. Those passwords are pre-shared keys. Unless it's username plus password, it's not enterprise Wi-Fi or a captive portal page.
No username. Well,
if it's no username, it's not. If it's just a password, if it's just a password that's the same for you and for Steve and for everyone, then
it's not enterprise.
It's not enterprise. If it gives you a landing
you can say
page,
90%.
Yeah, if it gives you a landing page, that's not a password. That's a landing page. That's called a captive portal. That's an enterprise feature where they let you in without.
It does give me that. That is what it gives me, but I have to put that password in there.
But it's on a landing page. It's not like the normal Wi-Fi dialogue pops like when you visit your friend's house.
Correct.
Okay.
It is the It is the captive portal.
Okay, perfect. That passes the test. If it's a captive portal, it's enterprise.
Okay, even though all I have to do is put in that dopey little password.
Yeah,
okay.
But it means that under the hood, it has those protocols like client isolation. They're choosing to use the captive portal to let you in, but that's the technology. It's using the fancy stuff. It's not a home router.
Okay. So we are not going to diagnose this right here, but just for completeness sake, on both of my Macs, when I turned on Private Relay, I got a pop-up that says, Private Relay unavailable. Software installed on this Mac is incompatible with Private Relay, and I'm not going to tell you which ones.
Oh, no, that's interesting. So you're running something I'm not running. That is very interesting. Okay.
And in system settings, it says, learn more, and it says, manage iCloud Private Relay for specific websites, networks. It says, it's just a web page. Maybe somewhere in here it's telling you that there's something. A third-party app such as a VPN or internet filtering software. I wonder if it's Tailscale.
Hypothetically, Tailscale may not want another app messing around with its DNS settings. Right? If you have two pieces of software trying to reconfigure DNS at the OS level, they may have a fight. Well, that is interesting.
Interesting.
I will leave it as a listener to the next listener to come in with a clarification on this, because I am so done explaining your last segment.
Well, this just in, it's not Tailscale. I turned off Tailscale and it still doesn't work. Unless it's just the existence of Tailscale.
It could just be
all
the
right,
existence.
we will leave that for the student.
Yes. Right. Into normal business.
And I'm going to cut us both off right there. If you want to hear the rest of Security Bits and everything else he talked about, head on over to podfeet.com and subscribe to the NosillaCast, where you get Security Bits every other week with Bart Bouchotts. I hope you enjoyed this episode of Chitchat Across the Pond. Did you notice there weren't any ads in the show? That's because this show is not ad-supported. It's supported by you. If you learned something, or maybe you were just entertained, consider contributing to the Podfeet podcast. You can do that by going over to podfeet.com and look for the big red button that says Support the Show. When you click that button, you're going to find different ways to contribute. You can donate one time through the big Donate button with a credit card or Apple Pay, or you can use PayPal. If you want to make a recurring contribution, click the Patreon button. Keep in mind, I don't charge Patreon for Chitchat Across the Pond or Program by Stealth episodes, just once a month for the NosillaCast. That keeps it simple. If you want to contact me for any reason, you can email me at allison@podfeet.com, and you can follow me on Mastodon at podfeet.com/Mastodon. Maybe you want to talk to other NosillaCastaways? You can do that in our Slack group at podfeet.com/Slack. Thanks for listening, and stay subscribed.